So for this demo, what I'm going to do is talk about functions and maybe derivatives. And so let's start with the definition of what a function is. Okay. So a function is a relationship between two sets. So we know what a set is mathematically. It's a bunch of objects. Okay. And so a function is a relationship between two such sets with objects in them. And so the objects could be anything. It could be numbers, or it could be other things like colors, names of students, and all that. So one example is a relationship between students and grades. And so for each student, there will be a grade. And so that is a relationship. And so not every relationship is a function. And so we can define these relationships in different ways. We can give a student more than one grade, but not every a relationship is a function. So what we are doing here is basically we're relating objects in here with the objects here. And so a relationship, a function is a special kind of relationship. It can be only of these two types. So that for one input, there is one output. And so this is one-to-one function. And it could be that we have many inputs giving same output. So it is many to one. And so here we can have more than one students, like different students, let's say two students having the same grade A plus. And it won't be that one student has more than one grade. He or she can only have only one grade. It could be C, D, or anything else. And so let's say we have how do we write it? The notation is, so we give, so one of these two sets is basically a set of inputs, and the other set is a set of outputs. I forgot to mention that, I'm sorry. And so let's say we have a student, John, and we give this input to the set here, F, and it outputs his grade, which is, let's say, A plus. And it could be that another student, Mary, has the same grade, and so it is a many to one relationship, and so it is a function. Similarly, we can have a set of parents of students in a class. So for students in a class, let's say we have fathers, and so it could be that there are twins in class. And so if we take this to be input, we can have one input and two students here in one class because we can have twins. And so this kind of relationship is not a function. Because we said earlier that we can have one input and one output, or many inputs and one output. And that kind of a relationship is a function. And so this relationship here between parents and students in this direction is not a function. But we can take students as inputs and fathers as outputs. And so what can happen is that two students can have the same father, which means we have a many-to-one relationship. And according to the properties of a set, it does satisfy the properties, and so it's a function. And so this was basically an intuitive example, or the definition of a set. And so in maths, what we have is relationships between sets of real numbers usually. And so the function is a relationship between sets of real numbers. Okay. And so we have a famous equation of a straight line, and we all studied it in our elementary grades. And so here, this thing is also a relationship. And by the definition of a function, it is also a function. Here, x is an input, and y is an output. And m is basically a constant, and c is a constant as well. And so this is a function. For each input, there is a unique output. And so it's a one-to-one function. And similarly, we could have other functions. Let's say y equals x squared. And so this is also a function, but this time it is many to one. Because if you see from here, for negative square, it's going to give us 4. And for 2 squared, it is going to give us 4 as well. So for two different inputs, we have a same output. And this means that this is a many-to-one relationship, but many is inputs and 1 is output, so it's a function. So what we have to keep in mind is that the output of a function is always 1, like it's a 1 number. It can't be that two different outputs are related to one input. Okay? And so what we can do is we know that if we have a coordinate plane, we can basically graph points in it. And for a straight line, we know that this is the graph. And the equation y equals mx c basically give us these points. So for different values of x, let's say x equals x1, we get a value of y1. Similarly, for x equals 2, when we plug in a different value here in this equation, we get a different value for y, and it is y2. And so what we can do is we can see from here that there's a unique property of this straight line that it has a constant slope. It has a constant slope. And it is defined as y2 minus y1, x2 minus x1. And so for a function different than a straight line, let's say y equals x squared, we don't have this special property that the slope is constant. And so what we get is something like this. Okay? And it's a function of x squared. And so this function doesn't have a straight, basically doesn't have a same slope at different points. It has a different slope at different points. If we try, let's say, calculating slope here, it will be different. Here it's different, and at the bottom it's basically flat, right? And so how do we calculate slope? And the mathematical machinery to calculate a slope is a derivative. And so maybe in the next session we will talk about slope.